This is Twit.
Bandwidth for Know-How is brought to you by CacheFly.
Today on Know-How,
Networking 101, Part 1, Routers.
welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Palliser.
And I'm Brian Burnett.
And for the next however many minutes it takes, we're going to be dropping the knowledge on you so you can go home and geek out on your own. Brian, do you have to be somewhere?
No, I was just thinking, how much time is it going to take to drop this much knowledge?
Oh, it's a lot of time, man.
It's going to be around 50 minutes.
It's a multi-part droppage of knowledge, actually. This is going to take the better part of a month because what we've realized is there's a lot of people who ask us networking questions. And over the years, we've kind of trickled out an episode here about tapping, an episode here about art poisoning, an episode here about why. Well, it's good to update that. And more importantly, it's nice to put it all in one neat package. So what we're going to do is a Networking 101 series. We're going to take you from the very basics of networking, what you should know, what you should buy, and how you put it together so that people can actually make their own high-performance, low-cost network.
Totally. And as far as when I was first learning about routers, usually it was just like a question mark box that was kind of mysterious, and the only time I ever wanted to touch it was when something went wrong.
Exactly, and that's the problem, because what we're taught to believe, if you do the consumer router thing, is you buy the magic box, and the magic box works, or it doesn't. And when it doesn't work, you go buy a new magic box.
Yes.
Well, so much of that can be done away with if you have just a little bit of an understanding of how the technology actually works.
Cool.
It gives you the ability to actually buy the pieces that you want rather than buying a product and hoping that it does what you want.
It's all set up by default, no problem.
Yeah, just default, no password, default SSID. Just leave the security, will be fine out of the box, and never upgrade the firmware.
Right. And we're joking.
Yes,
we're definitely
seriously.
joking.
If you've done that, then you should stop doing that. You should feel bad.
You should feel bad, and you should stop powering your router with your tears.
Your network is bad, and you should feel bad. Okay, but no, let's jump in. We got to talk about the basic, the thing that we're all going to need if we want to be on the internet, and that is
a modem.
Well, yeah, but
pay for Comcast.
That comes from your provider.
Oh, right.
The router.
But
actually, I'm glad you brought that up because in a lot of cases, the modem and the router are the same.
And in those cases, I usually hate them, especially if the case is Comcast.
Yeah, it used to be that your provider, be it your DSL provider or your cable provider, or back in my day, your, ISDN provider,
wow,
your T1 provider, they would give you what was essentially an entrance into their network.
And that came on like a little horse and buggy kind of contraption. They dropped that off.
Yeah, it was dropped off by storks and pelicans. It's, I got a brand new internet. No, but it was kind of slow back in my day. Thank you for reminding me that. But the whole idea was that device gave you real internet. So it was your real address, it was your real connection to the internet, and then it was your job to have some sort of device that would allow you to turn that one address or 2, 3, 4, a dozen addresses into something that you could actually use.
Okay. Well, just right before we get to the routers, because it does go from the modem to the router in most cases. The thing I have an older modem that I actually bought, and I paid for, and so it's it's paid for itself because I don't have to rent it anymore from the ISP. But they've been calling me, telling me I need a new modem.
You do, okay.
And I bought one, but I have not put it in, and it's still the old one's still working.
Well, the old one may be working, but you're probably not getting the most speed. So what they've done over time is they've upgraded the version of DOCSIS. That's the communications protocol that they use in order to connect your computer to their network. The older ones will work as they're backwards compatible, but the older ones typically don't allow as many channels, as much speed, as much bandwidth.
Okay.
Now, if you're not using a lot, then you may not notice it, but I mean...
I'm locked in at 35 down, 5 up.
You could probably get more in this area.
Okay.
So you may want to do that. Yeah, I'm with you. I used to love to buy because I didn't like paying a rental fee. More recently, I've just kind of surrendered because
you've given up.
I've given up because, like with Cox, with my family up in Las Vegas, they have to use Cox cable, and Cox would do something where it would require, if you bought it, you'd have to like rebuy one every 12 months. And that was annoying. It was like, well, yours will work, but you may notice dropouts. Or in the worst case scenario, something happens, your network doesn't work, and now they say, well, you bought the modem and it's not ours, so we can't be responsible for it, so go screw.
It makes me so sad, though, especially since they've beaten you down, who's usually the person who's the most...
Well, I mean, if it was my personal modem, I would absolutely do that. But I mean, it's like
you don't want to have to deal with it because it's your family stuff.
Yeah, I can't tell my parents, yeah, you're just not going to have the internet for the next 3 weeks before I get there.
Or, Dad, did you touch the modem or router again? Because
it's in the wrong side of the house, Dad. All right.
Okay.
So let's go ahead and jump into routing. Now, when we think about routing, this is the core language of the internet. This is how the internet works. I mean, a lot of people know the story of the internet. It was a DARPA project. The whole idea is, could you make a redundant sort of self-healing network, a network that could route communications from one point to another, even if you disrupt local nodes? Because before that, our idea of networking was something like token ring, where you would literally have a physical ring of computers, and it would pass a token, which was permission to speak, down the ring. And if you removed it from any of those nodes, suddenly the entire thing went down.
Wow.
Because you had an empty node on your ring, right?
Right. That makes sense, though, the early days.
Yeah, and in the early days, see, you don't remember this, but I remember when like one person would decide to move his computer, so he like pulls all the plugs out from the back of his computer, it took down the entire network.
Wow. Yeah.
I mean, we wouldn't put up with that today.
That is not sustainable.
No, totally not. But back then, it was like, networking was so new. It was like, oh, they're connected. Well, it's not connected right now, but when it's connected, whoa!
Pretty cool. We can send each other a message, maybe.
Well, back then, you got to remember that the network stacks were really insecure. So it was, I can take over your computer.
But then what could you even do with that computer?
No, make solitaire.
Print something out on the dot matrix printer?
Know, I'm feeling so much hate.
It's not hate.
The elders of computing. I don't know.
I'm just trying to appreciate the nostalgia, that's all.
All right, let's get back into the nostalgia. Let's talk a little bit about what it means to route, because a lot of people, since your magic box has both a router and a switch, and probably wireless as well, they kind of conflate them. They think routing is the same thing as switching, and it looks like that because even the plugs are the same.
Right, they have blinky lights, just like both of them just blink at me.
Precisely, so they must speak the same. Not necessarily. Even though on the back of your consumer router, both the WAN port and the LAN ports are using Ethernet, the core technology governing each is slightly different. So when we're talking about switching, we're talking about multiple computers connected to the same switch, right?
Right.
Well, that switch needs to figure out a way to direct communications, Ethernet frames from this computer to this computer. So what it will do is that switch, the memory inside that switch, keeps a table of everything that's connected to it. All the different computers, right? Because remember, every computer has a MAC address. That's a unique, that little 16-digit alphanumeric thing.
Right.
That is unique to that computer.
Identifies it, yeah.
Right. The first time you turn on the switch and turn on the device, that registers with the port that it's connected to. It keeps it in memory. It says, oh, anytime I get communications for this MAC address, it's connected to that port.
Right, and then it also assigns an IP address to it, right?
Well, IP is later on, so IP is higher up in the stack, but at the switch level, you're only speaking in those frames, those Ethernet frames.
Oh, okay.
Here's the thing, this is great. This works really, really well, because the way we used to do it was we used to use hubs. And hubs were just repeaters. So all they did was any traffic it got, it sent out to all the ports. It's like, hey, is this any of you?
Right.
And the one computer that was like, that's me, but everyone else could hear. It'd be like all your neighbors in your apartment building yelling at each other every time they want to talk.
Okay, yeah, that would be irritating. And it would be insecure, yeah.
Very insecure. And what a switch will do, a switch will actually, after the first time, once it's registered who is who, when your communication frame goes out and it says from this computer to this computer, it will only deliver to the port to which that computer is connected to. And so it'd be like picking up the phone and actually dialing someone in that apartment building. Much more efficient, and it seems like, oh, that's a great way to communicate.
Yeah, totally.
Except this. What if you're not connecting 64 apartments or 100 apartments or even 1,000 apartments? What if you're connecting like 100 million apartments? The table that you would have to maintain to know where everything goes would be unimaginably large. It's unserviceable.
Yeah, and then try and search through it to find the one that you need. Yeah, that would be insane.
Yeah, you can't do it. So we have routing. Routing is not switching. They look the same if you're just thinking about, well, I connect to this, I connect to this. But routing, rather than using a table, a complete table of everything that's connected, instead it has what are called route tables. So it's like,
So like a subset?
Kind of, exactly. It's I don't know exactly. Let's say I want to go from this computer to this computer. And it's connected from here to here. That's connected to this one and this one. That one's connected to that. That's connected to this one. That over to there. Some weird, right?
It's a weird web.
That's how the internet is. The internet is just this weird interconnection of different networks.
Right.
But what routing will do, specifically BGP, Border Gateway Protocol, it will allow me to not exactly know where the computer is that I'm trying to communicate, but to know enough that I think it's probably in that direction.
Okay.
So all of these routers will keep at least a little bit of the direction, the map that packets need to be sent in order to reach their destination. And so we'll go from here, it'll say, look, I'm looking for 10.50.50.50, and this one will say, well, I don't know where 10.50.50.50 is, but I know where 10.50 is, and then we'll send it over to here, and then it's the same question. Maybe that goes to there, that goes to there, then it goes over to here.
Right.
That's how routing works. This is super simplified, by the way. If you want me to get crazy complicated, you got to watch my other show, This Week in Enterprise Tech. That's not what we're here for. But in a nutshell, that's the difference between routing and switching. When I'm routing, I'm going between networks. When I'm switching, I'm going between devices on the same network.
Okay, that makes sense. I can knowledge absorb that. I mean, I do have a question about, is that what DNS is then?
Yes.
I don't want you to have to go too deep.
No. This is important because DNS has recently become very important because people are attacking it. I don't actually need DNS ever if I know the IP address. So if I know the IP address of a server, like I used to have a block of IPs that are memorized because they were mine and I had servers on them. Or for example, like OpenDNS is 208.67.220.220. Google DNS is 8.8.8.8. Yeah, so there are a couple numbers that you remember, but those are all IPv4, by the way. We'll talk about that in a little bit. What DNS does is it allows me to have a service that when I type in Reuters.com, I don't have to remember that Reuters is 12.13.52.12.
Right.
It actually looks it up. It says, hey, what is Reuters? And it will say, oh, Reuters is this IP address, and then that's what it sends out. So when I'm talking to another router, I'm not saying, where's CNN, or where's Fox, or where's Banggood? I'm saying, where is this IP address? DNS allows me to resolve a name back to the IP.
Okay, so it's kind of like a routing table.
Yeah, it's the same idea. You keep a table of what is what.
Okay,
Right.
cool.
So that's routing. And it's important for us to know this because that device, that magic box, is part switch and part router. Those LAN ports are all switched.
Right.
That WAN port, that's actually that's a routing port. That's connected to another network. That connects your network
to the world network.
Well,
the World Wide Web.
The network of your ISP, which is connected to the world. You got to remember, this is all layers and layers of connectivity.
You're right. It's an onion of internet.
And like onions, they make you cry.
There's a few ogres out there too.
Yeah. Okay, so let's get back to the basics. We've already talked about what a switch will do. We've talked about how it keeps a table. We've talked about how routing actually jumps from network to network until it reaches its destination, and then it can come back because it kind of has a map already, right?
Right.
But here's the fun thing. With this, because everything is interconnected, if I lose a node, there should theoretically be enough interconnectedness between all the different networks that make up the internet that I can still find a path. It may not be the shortest path anymore, but I should still be able to go around any damaged or unresponsive node of the internet.
Okay, so it's kind of like a redundancy plan or something.
Yeah, well, that's what it was built for.
Cool.
Yeah. So when we're talking about routers, there's a couple of different ones. There's the edge router. That's what we have. And it's think of a network as a big circle. The edge, it hangs off the edge, right? So those are the little edge routers. Those are me, right? Like, this might be my ISP.
Right.
All the edge router is designed to do is it's designed to take the routed traffic and turn it into something my network can understand. But then we take a step back up from the edge, and from the edge you get the subscriber edge, and that might be like Comcast. Or AT&T.
Or Cox.
Or Cox, right? So the subscriber edge routers are designed to connect to the edge routers. Go one more step up, and now we have the border routers. The border routers are, well, they're the ones, the big iron, that connect across networks. So imagine this. Imagine your router has to carry your traffic, right? Go a step up.
So then the ISP router has to handle all their subscribers' traffic?
Right, precisely, exactly. So that subscriber edge has to handle all the traffic of all the edge routers connected to it. So it has to be a bit more, well, actually a lot more powerful.
Okay.
Go a step up. The routers that connect subscribers together. And remember, those subscriber routers are connected to all those edge routers. They have to be really big.
Yeah.
And they have to have a lot of power and a lot of memory to be able to handle that, right?
I'd like to see one of these facilities.
I've got one if you'd like.
Yeah, okay.
And then you go one more step up, and it's now we're kind of splitting hairs. We're talking about the backbone routers, and these are the big boys from HP and from Cisco and from Huawei, and all they do all day is route all of the traffic between, like, it's to which the internet is connected. It is basically the internet.
Interesting.
Yeah, right?
I want to see these, actually.
Oh, good. You could
Maybe
watch
someday.
This Week in Enterprise Tech.
Is there a show that would talk about this?
Is there a show on the TWiT TV network that talks about enterprise technology?
No, it would never happen.
No.
It would never happen.
No, sorry about that. Okay, but we're not talking about that stuff. We're bringing it in just so that people understand you're one little piece of a huge, huge network.
Right.
But let's talk about what your router does, because your router is different. It is a router, but it's a router with some built-in functions for consumers.
Right. Okay.
And there's 4 main functions that you have to think of when you buy a router. The first is NAT, Network Address Translation. The second is DHCP, Dynamic Host Control Protocol. The third is the firewall, which is actually linked into the NAT functionality. And the fourth, and this is actually relatively recent, wireless.
Okay.
So those are the 4 pieces that we kind of expect. When we buy anything from a budget router up to the high-end router for the home, it's got to include those 4 pieces.
Okay, yeah, that makes sense, because you just want to connect the devices that you have at home, and if you've ever had a gaming console, you've probably run into a NAT problem before.
Exactly. So let's talk about NAT. NAT is Network Address Translation. Some people don't know why we have NAT, and again, the older people will. And the reason why we have NAT is because back in the 80s, I know, the world existed.
The 80s, you say?
80s.
Oh, okay.
We were alive.
There were people before me?
Young people. Okay, back in the 80s, IPv4, that's the IP addressing, that's the scheme number 4, which was based on 4 octets.
Right.
Basically, 256 values, 256 values, 256 values, 256 values. Well, multiply that, you get a whole lot of possibilities. And we thought, that's so much, we'll never need that.
Yeah.
It's, back when the internet was still really, really small.
Right.
And we were able to, for example, I owned a Class B. I owned a chunk of the internet. And they just gave it to me because we were a company and we did some research. And I gave it back, but I shouldn't have, because the thing would have been worth millions. But you got to remember, back then, every device we connected to the internet was actually connected to the internet. You could see it. It had a real IP address.
Okay.
Because that's what we did.
Right.
Because we had so much space, we're like, well, why would we do anything else?
Right.
Towards the mid 80s to early 90s, we started hitting what was called IPv4 address exhaustion. We had handed out so many addresses, and most of them weren't actually being used, that we were running out.
Right.
And people were thinking, okay, we're going to have to switch to IPv6. It's the one that we're using now, which has enough addressing space to give an IP address to every atom in the universe.
So we'll never run out again.
But no, this time we really won't.
This time we won't.
We really, really won't. But what we did, instead of switching over, because we're like, oh, well, I don't want to replace all my equipment.
Yeah.
All my equipment was designed for IPv4. If I do IPv6, I have to replace all my switches. I have to make sure that all my computers can be stacked that way.
Right.
We did what was called NAT, Network Address Translation. It was recognized that most of your devices shouldn't have a real internet address. In fact, that was bad. I don't want people to be able to directly access my device.
Right, that makes sense. So you should get one, and then you kind of disperse that amongst your machines.
Precisely. I need one real address because the internet needs to be able to address my network.
Right.
In order for me to be a router
talk
on
back
this,
and forth, yeah.
I have to talk back and forth. So I need one real address. But once I've got that one real address, that device, which is my router, can talk to all the devices behind it. They don't actually need a real world address.
Right, right.
And so what this meant was I could take a single address and I could turn it into as many computers as I want, any nodes as I want.
See, that makes sense, because if, like, the way I'm imagining it is if you had a house, like, you would just have one door to go into the house, and then that's where you have all your stuff, instead of just like a bunch of doors leading to all the different rooms of your house from the outside.
Yeah, and there was good for security, because it meant that if you were trying to hit my network from the outside world, you could see that one device, but you couldn't see anything else behind
Past it.
Yeah.
Okay.
Yeah,
So,
right?
all right, then that helps take care of that. But what is an open NAT versus a closed NAT?
Oh, we'll talk about that when we get
Okay.
to firewall. Don't worry
We'll
about it.
get to that? All right.
Because there needs to, sometimes I do want the internet to be able to hit a device behind that layer.
Right, especially if it's a gaming machine
Especially
that
if
you
it's a
have
gaming
to, talk on different ports with.
Precisely. And so we'll talk about that when we get to firewall. But first I want to go to one of the other features of your router that most of you probably don't realize is there. Maybe you've heard the name, but you don't know what it does. It's called DHCP. This is really, really important. Again, back in the day...
Can we just go black and white whenever you start talking about that?
Put some lines across the screen.
Yeah, make it look like VHS.
Yeah, change the vertical hold just to make sure we stay in place.
Vertical hold?
But you got to remember, when we all had real addresses, before DHCP, I had to know all the information for my addresses. I had a notebook. It's not a computer. I had a notebook.
Oh, that's sad.
Like with pencil that listed my range, and it was like, okay, which MAC addresses have I associated with which addresses? That was,
wow.
It was a crazy fancy system.
Oh, I bet, yeah. And then you carry your notebook around with you everywhere?
Oh, yeah. And if you lose your notebook, you just lost your table.
That's bad.
No, but what DHCP does is it allows a computer, a node, a device, to request an available address from a central authority that will work on that network. And so what it needs to be able to do, it needs to keep a table to make sure that it's not giving out an address that another computer is already using.
Right.
And it also needs to make sure that every once in a while it expires those addresses so that the clients will request a new one, just so it could keep it refreshed. Okay. In the old day, you don't see it much anymore, but back in the Windows 98 days, 95 days, people were so accustomed to seeing a little window pop up saying, that IP address is already in use. Contact an administrator. And it's because someone else has jumped onto your IP. And it was a cascade. Okay, we're totally getting off the rails. But there was a cascade effect. The people who knew just enough to know where to change that, they're like, well, someone takes my IP, I'm going to jump on another IP. And then it would just down the chain. Everyone's like,
oh, wow.
I'm knocked off. Hey, who's on
It was
my
snowball kind of effect.
Yeah, and so you'd have administrators who are under no circumstances are you to change your IP address. If you have a problem, you call us. We'll come over and see what happened.
Okay. So if two machines were trying to use the same IP, then just one would be able to access and the other one would just be like, I can't be addressed to the internet kind of situation?
Well, the last one to request, or the last one to take it, would actually have priority.
Son of a gun.
But you got it's the way that it works. Basically, the computer screams at the switch.
Yeah.
Says, "I am this. I am this," and so all the traffic will be directed to that. And if you have two that are trying to both claim that I am this, whichever one did it last gets the traffic.
Okay.
That's
Me.
Yeah, basically.
Yeah.
Okay. And actually, that's an attack. That still works, and we'll explain that next week.
Wow.
Yeah.
This is cool.
It is cool. DHCP it's actually a quick process. So we go from discovery. And so when you plug in a computer, the very first time it connects, it does what's called a DHCP discover. So it sends out, it's a broadcast message. So let's say my network is 192.168.1.1. That's my router. It's going to send that 255.255.255.255. And that is the special address. That means it's going to send it to everything on the network.
Isn't that is that called the subnet mask or something?
Well, that is a subnet mask, but this one's this one's called a broadcast address.
Okay.
And so when I'm sending something to that, everything on the network is going to get it, and it's basically the client saying, "Hey, I'm new here. Could I get an address, please?" And it will wait. And it will wait for someone to give what's called an offer. So you have DHCP discovery, then you have offer. And the offer is the DHCP server saying, oh, hey, okay, did you want an address? Was that you requesting an
That
address?
was me over here. That was me. Yeah.
And then from that, it's gonna the client is gonna do a DHCP request. So it's no longer a discovery, but it's a request, and the client's saying, yeah, that was me. I need an IP address, and then the server should acknowledge it's a DHCP acknowledge,
right?
Sending back to the client, okay, this is the address that you can use.
Right. Okay, so that's happening all automatically.
That's all automatic. It's a 4-part process that, I mean, you take it for granted.
Right.
It did not always exist, and it was so much better once we got it.
So before that, before DHCP, would it have been what you would call a static address, where you had to, this is the IP for, yeah, okay.
Yeah.
Because I've had to do static IPs before.
Yeah.
And that just means that machine always gets that IP address, right?
Precisely.
Okay.
Precisely. Or because sometimes, I mean, we'll explain this when I get to next week's episode when we actually set one of these things up. But what I will typically do is I will have a range that DHCP pulls from, and then I will have a range that DHCP doesn't touch. And I know those are my statics. But I got to maintain my statics. If I drop 2 on top of the same address, it's going to be the same problem that we had back in the day.
Okay, smart. I like that idea, because the issue I would have is I'd turn off a machine and then turn it back on, and it would have a different IP if another machine had taken that. Yeah.
Fun stuff, right?
Okay.
Grrr. All right, so we go from that. The third feature that you're going to expect is a firewall, and you hear this all the time. I've got a good firewall.
Yeah, it's impenetrable.
Do you know what the firewall actually is, Brian?
I imagine like a Tron situation where it's actually just a wall of fire and the little motorcycles can't get through it. Isn't that what it's
actually?
Is that it?
Thank you. We're
Sweet.
done. Thank you, ladies and gentlemen. If you need to know more, please go to our show note. No.
See, all the inner workings of computers just go back to Tron for me. It's just little people and motorcycles going around, which I like to think about.
Yeah. Now the firewalls I deal with are actual firewalls. I mean, like I have one.
Walls of fire.
Well, yeah. No. With propane. Yeah. No, but I've got like Sonic Wall, which was Dell. Now it's Sonic Wall again. Those are enterprise class firewalls, which can look at every single packet, and I mean they're really good with rules. The firewalls that we build into consumer routers, yes, technically they are firewalls. They are firewalls. They're not that advanced. Typically, what they are is they're paired with the NAT, the address, a network address translation, to enable and disable ports.
Right, because all the ports open would be bad.
That would be bad. Yeah, we don't. That's what it used to be. It used to be when you would plug your computer into the internet, everything was open. It was just like,
because it's
I trust you.
It was like a 1950s happy, like Leave It to Beaver neighborhood,
Do you
right?
compare everything to TV?
Sometimes.
Okay.
Yeah, the things I see on TV, yes.
No, so in your consumer router, your firewall will basically allow you to open and close ports. Like for example, for your gaming device.
Right.
You would tell that any traffic I get, the router, so I'm talking my router, any traffic that my router gets on port 8862 will get forwarded, and I make a rule, a firewall rule, a routing rule, will get forwarded to the inside of the network to the device that is connected at 192.168.1.5, which is a non-routable address. That address can exist in the real world, but it does exist in your network.
In my network, yeah.
Right, and in that case, because there's 65,536 different ports, of which I have access to about 65,000 of them.
Yeah, whatever.
Yeah, I have a lot. I can make rules, firewall rules, routing rules, that will take all those different ports and route them to any address I want inside the network.
Right. So you have full control then.
I do.
Which is
but
nice.
I do want those, we'll talk about this when we get to security. I want those to be closed by default. I don't want any ports open unless I specifically want that communication to take place.
Okay.
The other thing that the firewall will do, on better units, you get what's called Stateful Packet Inspection, SPI. It's not just the rules of where traffic goes. It's looking at the packets for maliciousness, malformed headers. The nicer routers, like the Synology that I'm using, can actually see attacks. It knows what an attack pattern looks like.
Okay.
And it will try to keep that traffic out.
Huh. So it's So I'm imagining, all right, here's my little, I'm imagining the packets coming through the router, little dump truck. It's like going through and there's like key items or there's like filters that it looks at and it's like, oh, this is something I recognize. That's like a bad thing.
Yeah, exactly. And again, it all depends on the power. Some routers, when they say they have stateful packet inspection, what it really means is the router's going, yeah, that's a packet. Yeah, that's a packet. That's a packet. Oh, yeah, that's a packet.
As they just blow by.
Technically it is, but it's not.
So is that really like CPU intensive? Like, is that something? Yeah. Okay. And so if you do, I guess you would have to have a nicer one to.
You'd have to have a nice one, or one that
notice a slowdown.
Has built-in silicon. Like when I was still doing interop, I worked with a company called cPacket, and that's exactly what they did. They made custom silicon that could look at every packet in a 10 gigabit connection. Which is a lot. That is a crazy amount. And literally, they could say, search all of these packets as they in real time, as they come in. Don't store them up, but as they come into the network or go out of the network, search for anything that says password. And anytime you see a packet that contains the word password, stop it.
Okay.
And it sounds simple. That is an amazing amount of processing power that you need to do that.
And to do it quickly, right?
It's got to be real time. You can't. I mean, it'll add a tiny, tiny, tiny bit of lag if you have the right hardware. Otherwise, it will just slow you down incredibly.
Okay. And you had said malformed header. I'm just kind of curious. What is that?
As I can actually, so when I'm communicating, I'm setting off a packet of information. I can compromise someone's poorly configured system by sending a malformed packet that, when opened by the router, will do something different than what it expected it to do.
Oh, okay.
That's the most layman terms explanation.
Explain it to me like I'm 5, Padre.
Okay, so the packet comes into your network and it tears off its disguise. It's like, I'm Old Man Withers and I'm stealing your gems.
Curse you, old man. Okay.
And of course, the last part is wireless, which we know what that does, and we're going to cover that when we get over to that part of the networking 101.
Okay.
But in a very long nutshell, in a 30-minute nutshell, that's what your consumer level router does. And the reason why we did all this, and the reason why this is important, is because you need to understand when you buy that box, you're actually buying at least 4 different devices that back in the day we had to get individually.
Right. It's all in one, and it's probably a lot cheaper than it used to be.
It's a whole lot cheaper. But I mean, it also means that, there were some sacrifices to get everything down in that package. I mean, we used to have to configure our own routers. We used to have to build our own NAT box. We used to have our own DHCP servers. We used to have our own firewalls, and we had separate access points that we would set up.
Right.
Now it's all contained within one box, but you still have those discrete components in there. You need to know what they do, and you need to understand what's running, because you're going to configure your network the way that you want. That's how you get a high-performance, low-cost network.
Pretty cool. I think it's fascinating to know all the different components, but one last question I kind of have about firewall is, isn't there like hardware firewalls and software firewalls?
Yeah, and that's exactly what I was talking about. Hardware firewalls have custom designed chips. Like SonicWall, they build their own silicon. cPacket, they build their own silicon. Even the failed startup that we had not too long, Guardian, remember Guardian?
Yeah.
That was a custom ASIC that they had designed just for throughput, because you can design chips just to do one function really, really fast. So instead of, the problem with the software firewall is most of them run on general purpose CPUs.
Right.
And that means they're never going to be as good at their job as a custom design ASIC, because they've got all this overhead that the custom design ASIC doesn't. It's like when I'm running a software firewall, I'm running it on top of a CPU that could do everything. It's the happening guy. I could be a fireman, I could be an artist, I could be a cop.
Right.
I can't be any of those things exceptionally well, but I can do everything.
Okay.
The custom ASIC is like that guy who's like, I sweep.
And that's
really good at sweeping.
Yeah, like instead of being a jack of all trades, you're the master of sweeping.
Precisely. So you take silicon and you have it so that all it does, like the cPacket example, is it does SPI. It can open the packets, look, and send them off. Open the packets, look, send them off. That's what it does. Does it very fast. A bit more expensive, but performance, I mean, you can't compare them.
Okay. Now I'm thinking, because there's Windows. Windows has firewall built in, right? Or
that's different.
Is that different? So it's not like I want to go into my router and turn off the firewall settings in there because I'm like, oh, I already have a firewall on my computer, so why would I need to double up?
Yeah, the Windows firewall, that's basically just port blocking.
Okay.
It just makes sure that the services are off that shouldn't be on.
Okay. And then asks you, like, do you really want to open this port? Or?
It's good. It's not like junk.
Right.
But they're both firewalls. They just do slightly different things.
Okay, cool. Cool.
All right. When we come back, we're actually going to start taking a look at one of the routers that maybe you should buy. But before that, let's take a moment for these messages.
Previously on Twit.
NASA is feeling a little Oprah Winfrey at the moment and has decided that everyone in the world gets a bunch of their favorite software for free. You get a global reference atmospheric model for Earth, Mars, Venus, and Neptune. You get an app that calculates the Boolean subtraction of arbitrary watertight triangular polyhedrals. We all win, people. Yes!
There was no NASA software under my chair.
The new screensavers.
Hey, you know what you can make from crickets? You can make cookie crisps. These are made out of cricket flour. Crickets are all the rage right now. They're so good. Come on, Kevin.
Security Now.
A company that sells internet-connected teddy bears left more than 800,000 customer credentials totally exposed online. But suffice to say, these pets do not use any pairing. Anyone within Bluetooth LE range is able to connect to a child's cloud pet and upload their own content.
Twit. Kid tested, mother approved.
I'm very
making the
interested.
switch?
How about, yeah, maybe. It's not exactly vegetarian. I mean,
Yeah, what would that be? It's not pescatarian.
It's bucketarian.
It's like cricketarian.
So not too long ago, we were at CES.
That's right. That's right. Actually, it was what? January. It was January. It's gone by fast.
It feels
though.
like a long time, doesn't it?
Yeah, it does. It feels a lot longer, yeah.
Well, while we were there, we did manage to stop by the booth of one of my favorite companies. They make, well, what I had was their NAS boxes. I love their NAS boxes. Feature rich, super dependable. Of course, I'm talking about Synology. But recently, last year, they introduced a router. And at first I thought, why is a NAS company giving us a router? Right. But they had some serious chops. Well, we went back this year and, well, they wanted to tease the second version. This is the Synology RT2600. I want to talk about something that last year blew me away, and that was Synology's release of their first ever router, the 1900 AC. Oh, yeah. Fantastic product. We've recommended it to our audience. I run one at home. It's probably the best router I've ever had, and I use it for more than just routing. Again, it's got my VPN, it's got a media server, it's got a DNS server. You've updated it. Yeah. Tell me about this one, because this is a monster. It's beautiful, and I want to know what it can do.
Well, this is our new router, as you mentioned. It's called the RT2600 AC. It should be released in the US later this month. As you can probably tell, if you're a router aficionado from the name, it's a 2600 class router. That means that when you have both of the bands running, you could get up to 2.5 gigabits of simultaneous connectivity. And it comes with all like the newest Wave 2, 4x4 MIMO, all the specs that you want from a router in this class. But I mean, as you've been mentioning, the really special thing about Synology is our software. We've taken our expertise from making a user-friendly operating system for our NAS, and we've applied that same experience to the router, our router over here, just in order to provide a really easy, intuitive user experience for anybody who might not really know about networking or how to log into a router backend.
And that was one of the things that impressed us about the RT1900 and now the new 2600, which is it's a router that an expert will love, because I can do things like I can find out exactly how much every device is using on my network or how much every service is using on my network. I can do per user lockout, but also this device will update itself. I can set it up for my parents and say, don't ever touch it, it will take care of itself. But I gotta ask, this is kind of a pricey device. I mean, we're talking about $300 for this, which is where the other router started. why would I buy that? If I was an end user, if I was a typical consumer, how would you sell me on buying what, to me, sounds like it's too high end of a device? It's something that's way overkill.
Okay. Well, first of all, the pricing in the US hasn't been officially announced yet, but it should be more something like 220. Well, which I believe is actually pretty reasonable when it comes to a 2600 class router. Now, the thing that you mentioned a little bit ago is the fact that you can run your VPN server on this. You can run DNS server. You can actually use our application called Cloud Station. So this could become your file syncing hub, so that you could sync files from your computer to your phone, back to the router, and you can access them from anywhere. And then when it comes to managing the network, well, this comes with application layer QoS. Have you heard of that before? And what that does is with old traditional routers, if I wanted to limit your bandwidth, the only thing I could do would be to select your device and say, this device can only use so much bandwidth. But with layer 7, actually, I can go a step further and I can say, when this device is using something like this music playing app, restrict the bandwidth. But let him use all the bandwidth he wants to when he's using other applications. Now, a couple years ago, if you wanted a feature like this, you would have had to buy some really expensive, dedicated, professional level hardware. So for that, I'd say this is a pretty good deal. And actually, that's something that we really tried to do at Synology is bring these professional level applications down to the ordinary enthusiast user space. Yeah.
Patrick, thank you very much for speaking with us. Now, if they wanted to find out more about Synology's products, everything from your NASs that are more than NASs to your routers, where can they go?
Oh, well, they could go to our website, www.synology.com, or they could also follow us on Facebook or Twitter.
Thanks again for your time. Synology, it's not just storage anymore. I got to say, I've had an RT1900 AC in my network since I bought one right after we got the review unit. It's amazing. I mean, it's great. I have noticed that if I push a lot of traffic at it, a lot of packets, I do start to see a little bit of decrease. So there's a bottleneck.
But when you say a lot, that's like way more than the average user, right?
If an average user is pushing as much traffic as I'm pushing, they're doing it deliberately.
Yeah, exactly.
Just to mess up the router. Yeah, but I mean, I did notice it, and it's like it's a higher end. You're talking about a $200 router. You kind of expect a bit more, which is why I'm so happy that I got the 2600. Now, this was the review unit sent to us by Synology. I actually bought one of these because I wanted it now. So it's replaced my 1900. I've got this. This has been purring away in my data center for about a month and a half now. And I got to say, man, it is.
Is it sweet?
It is sweet. It works just like the 1900, but I'm not seeing that slowdown when I'm pushing a lot of traffic. So obviously they've done a little bit of reworking. The processor's a tiny bit faster. It does look a lot like that 1900. I mean, the same basic shape, the same basic design. It's got 4 MIMO antennas, which it's a nice way of saying multiple in, multiple out. This is one of those devices that allows you to send multiple signals and then receive multiple signals so that you can, increase the bandwidth.
Got a lot of vents for ventilation, so that's good.
Yeah. Well, I mean, you're gonna be using them. This thing does.
It's gonna get hot.
It's gonna get hot specifically because it does so much. There are so many features. Here, you want to go ahead and install the antennas?
Yeah, sure.
Yeah. How about that?
Nice.
Okay. We got something for hippo. Now, let's run down the stats on this thing because it is a pretty decent device. We're talking about a quad-core Qualcomm IP. Is it a Q8065? It's a 1.7 gigahertz processor. It's faster than the 1 gigahertz Broadcom that we had in the original 1900. And of course, if you go back to the overhead or the side, this thing is kind of large. Don't expect
large
it
and in charge. I'd say like the 1900 is probably about that big.
Yeah, and a little shorter, a little lower. I've got 512 megabytes of DDR3 system memory in this thing, 4 gigabytes of flash. That's twice that of the RT1900 AC. The reason why that's important is the more memory I have, the more overhead I have for running the apps, because this has a bunch of plugins that I can turn on and I want to use them all.
That's what I was going to say about this. The thing I like the most about the Synology is that all the software that comes with it. And if you've ever kind of cheaped out on a router like I did, or used an older router, the software was the bane of my existence.
You've got the 1900 HC, right?
I do have the 1900.
Isn't it nice?
Oh, it's sweet.
Yeah. So also I've got on the back, I've got all the standard ports. So I've got my gigabit WAN port, and this does support 2 gigabit. I've also got 4 gigabit LAN ports. However, one of these can actually be reassigned as a secondary WAN port.
Oh, so if you had...
Yes. Okay. So if you had, say, cable and DSL, you could connect both of them, mostly for redundancy. If one goes down, it goes up on the other. But I can also, it's a form of bonding. I mean, I can't really bond unless I've got bonding on the other side as well.
Right.
But what it can do is it can look at which connection is least saturated, and the next connection that you make goes over that.
Okay.
It's actually kind of cool. I really
bonding.
like it. Yeah.
James bonding.
Also, I have the ability to, with the interface, I can set certain devices to use a particular WAN. So I can say, hey, you know what? Everyone else in my house goes over DSL. I get the fat cable pipe.
Exactly.
Yeah.
Well, you can also do that in software too, because I've set my Xbox to be the where it gets all the bandwidth in case there's other things pulling on the network.
Well, that's QoS, and that's what this supports, quality of service. So I can use QoS rules inside of this, including like VLAN and the quality of service, in order to like segment the traffic the way that I want it.
Right.
This has also got one USB 3.0 port right over here. There we go. Yeah, right there. And it's also got a USB 2.0 port. It's got an SD card reader. Oh, there's actually the USB 3. An SD card reader, so that I thought this was kind of silly, but I've actually used it. I put a 64 gigabyte card in my 1900, and that's all the storage I need for apps. And then, of course, you've got that 4x4 MIMO antenna. Now, that's just the hardware. The wireless specs on this are actually very, very good. This is 802.11 ABG and AC. It's got dual and simultaneous radios at 2.4 and 5 gigahertz. Your maximum on the 2.4 gigahertz is about 800 megabits per second. The maximum on the 5 gigahertz is 1.73 gigabits per second. Yeah, that's 2x2 wave 2 if you're an AC fan. It also does beamforming, which is a nice way of saying it can use creative interference so that I can actually talk to specific devices without spamming everything else.
Right.
The OS on this, as you know, it's the same SRM that we've got on the 1900 AC. If you know how to use their NAS products, you'll feel very at home because it works the same way. I love the bandwidth monitoring. I love the QoS, the quotas, the access rules, so I could set like what time certain devices are allowed to connect to the internet. So if you're a parent, this is great because I can say, hey, you know, my kids' tablets, after 10 o'clock, they don't get the access to the internet. That's super easy. And we'll show that when we do the full review.
I even like that you can dial it in and change to when the LEDs come on and off.
Yeah, actually that's really important because those blue LEDs really mess up your sleep.
Yeah.
We're just figuring that out, but I mean, router manufacturers that have included that inside of this, that's forward looking.
Right.
The other thing I like, and this is the reason why I'm going with this, because if you go to the link there, Alex, this is not an inexpensive router. And this is $240.
Okay.
It's a fantastic way to spend $240. But the reason why I like it over some other routers that might cost $240 is support.
Right.
We've seen from D-Link, we've seen from Netgear, we've seen from a couple of other manufacturers that will sell, you know, pricey products.
Right.
And they haven't had their firmware updated in like 5 years.
Right. I'm trying to think of, it was that Linksys one that we had that I really liked it as a router, but they had promised that they were going to do open source software for it.
And
they but they waited like 2 years after it came out.
A long time. And that's where Synology uses their experience with the NAS market because they're really good about updating anytime they have an issue or anytime they want to add features.
Yeah.
SRM is the same way. I mean, I updated the 1900 maybe 5 times last year. And, you know, it's an automatic process. I don't have to flash anything. I just click upgrade and it goes.
Yeah, well, I have mine set to auto update and I have it set to times when, like, I didn't even have to tell it. I just said, just do it for times where I don't use the internet. And it was like, oh, at 3 o'clock in the morning, you're not usually on, usually. And it will do updates around that time. And it'll send me an email too, like, hey, like, I'm going to update myself in about 10 minutes, just so you know. One thing I forgot to ask, does it still have the buttons to turn on and off the Wi-Fi?
Yeah, where is that? There, right there.
Because that was something
here?
kind of new to me, that you could just be able to turn off the Wi-Fi without having just the physical button to do that.
We used to have that. Yeah. That used to be a very common feature, and it kind of went away. And I like it because sometimes I don't want to go into the setup. I just want to walk by the router and go boop.
Yeah.
And it's off.
Yeah, definitely.
And you cannot turn it back on. It doesn't matter what you do, it's off. It has been turned off. The other cool thing about this is, like you, I have it set so it will update, but I don't want it to go until I tell it to go. It will send me a text on my phone saying, hey, I just received an update.
Yeah, and can you reply through the text?
I could set it up to do that. I haven't.
Oh, okay.
I actually, I have the app on my phone, so I can just log in and go, yeah, go ahead.
Update is a go. That would be awesome.
Dinner out is a go. You don't know the movie, but.
What movie is it?
Spy Game. Robert Redford, Brad Pitt.
Oh, I should go see it. I like Robert Redford.
All right, yeah. Okay, but we understand that $240 is a lot, so we wanted to give you a budget option. This is what we went with. If you go ahead and show the link here. This is actually fantastic. This is the RT-ACR H13. It's a budget unit, but it's $70 versus $240. So we're talking, it's less than a third of the cost. You do take some performance hits, but I mean, it is still a very, very good device. We're talking about a quad-core Qualcomm. It's a 717 megahertz, so it's not nearly as fast as the one in the Synology.
Yeah.
But also, you're not going to be dueling nearly as much. In the Synology, I expect to be loading this up with apps.
Right.
With the Asus, this budget one, I'm basically only using it as a router.
Okay. Which probably for general people it would be fine, because you like to play with these.
I like to play. But it's got 128 megabytes of memory. It's got 128 megabytes of flash storage. It's got a gigabit WAN port, 4 gigabit LAN ports. It's got USB 3.0. So a lot of the same expansions without all of the bells and whistles. On the wireless side, it's also pretty capable, about half the speed of what you would get from the Synology. It does do dual band, so both 2.4 gigahertz and 5 gigahertz. It can do both at the same time. It does 2x2 MIMO instead of 4x4 MIMO, which means that on a 2.4 gigahertz network, you're going to get about 400 megabits per second max, which is half the Synology. And on a 5 gigahertz, you're going to get 867 megabits per second, which again is about half.
Okay.
So yeah, slower, but I
Still
mean
pretty
a
good.
third the price.
Yeah, and I think, so I realized Gregory, my little brother, is using a router that I bought when I was in my second apartment or something like that. So it's like 8 years old. And yeah, I think his birthday is this month. So maybe I'll pick that one up and give it to him. No? Don't do that.
I think you should buy the Synology.
Yeah,
and then give
him my old 1900. I could.
That's a lot of money, though.
I know.
I understand.
I really like my 1900.
Yeah. The other thing that I like about this, the Asus, is it just like the big boy. You can use it in bridge mode or in repeater mode.
Oh.
So I mean, if you're one of these people that likes to set up a wired network from a wireless network, that actually works really well. So you've got two choices. You've got the $240 Synology 2600, and you've got this the H13 from Asus.
Right.
Opposite ends of the spectrum as far as price is concerned. I will say, if you're thinking about a cheaper model, like some budget special from Best Buy, TP-Link is good, D-Link is good, Netgear is kind of good, but I would never buy those.
I don't know, just like all the headaches I've had from buying a cheapy router, like it's just worth it to me not to. But
when I know a company is going to keep updating their software, like I know with Synology, it means that 1900 may have cost me $200 last year. This one may have cost me $200 and some this year. But I'm going to use these things for the next 10 years.
Yeah, definitely. And I was just wanting to look it up. It looks like the Synology RT 1900, which is the one that I have, is 150 now.
Yeah, so it's gone down. Well, folks, that does it for this episode. I know this was a lot of information. No, seriously. And we definitely want to make sure that you get this because, Brian, I mean, we learned it. We learned it today.
We learned it. Are we done?
Yeah.
I wanted to keep talking about routers.
No. But next week, you see, because remember, this is a multi-part episode. Next week, we're going to be going over the basic router setup. We talked about all the theory. We brought out two of our favorites.
How things work.
We're actually going to dive in. We're going to show you the way that I would set it up to optimize performance.
Cool, because that's actually one of my favorite parts is playing with the software on the 1900.
Yeah.
Like the UI of it is really clean, and you can like dial in and see all the graphs and data and stuff like that.
Exactly. Yeah, it's a geek treasure trove.
It is, yeah. Nerd out.
Well, if you want to find anything about this episode, you need to go to our show page. Brian, where did they find that?
twit.tv/KH. And like Padre said, if this is a multi-part episode, you're not going to want to miss one. So subscribe and download while you're there.
Yeah, and also don't forget that you can find us on the socials. The best place would be to go to Google Plus and look for Know How. You got to ask to join. There's a very short approval process just to keep out the spam accounts. But once you're in, it is the best place to get ideas for projects, to get help with a problem you're having with one of your projects, or to post questions and pictures and videos that we can use here on Know How. It's how you can be part of the show. Again, go to Google Plus and just look for Know How.
That's right. It's all about the participation. But if you want to participate with us on a more direct level and see what we're doing when we're not like actually on the show, you can follow us on Twitter, and I am at @cranky_hippo.
And you're going to find me at Padre SJ, and you're going to find the third member of our team, Jimbo. You can find Jimbo at twitter.com/ANELF3. Jimbo's a good guy.
I don't think you're pronouncing that right.
No, I'm pretty sure.
Excuse me, Padre. It's pronounced Alex.
Oh, so close. It must be the dialect.
I don't hear the difference. Maybe it's my AFB.
That must be it.
Anyways, until next time, I am Father Robert Ballester.
And I'm Brian Burnett.
And now that you know how,
go route it. Network.